We are continuing with solving trigonometric equations. The problem is sine of theta over 2 minus 1 equals 0. The pattern of the problem is quite similar to what we did previously. The only difference is we have theta over 2 instead of theta. So working principle will be similar. Firstly, we will solve for sine of theta over 2. And then it becomes 1. This section is 7.4. Problem solving step will be, we will find the solutions with theta over 2. And then, so we find the solution with theta over 2. The problem is about solving for theta. So we will multiply by 2 to get the answer for theta. So the value we are getting is the maximum value of the sine. That implies that we have to figure out the solution with the sine graph instead of using the special triangles. So we are graphing the sine function like this. And we have to limit ourselves from 0 to 2 pi. And we are thinking about the inverse image of 1 between 0 and 2 pi, because this is one cycle. The only time sine value becomes 1 is when that is pi over 2. So in the first step, we have to find the solution with theta over 2. So we write theta over 2 equals the only solution in one cycle plus 2 pi, which is the cycle of sine times k, because sine is a periodic function. This is the period of sine. And then we have to figure out the solution for theta. So we multiply by 2 on both sides. So we start with theta over 2 equals pi over 2 plus 2 pi k. And then we multiply by 2 on both sides. So it becomes like theta equals the distribution. So 2 times pi over 2 plus 2 times 2 pi k. So theta becomes pi plus 4 pi k. WebAssign can ask you about the solution in the interval 0 to 2 pi. Then the only solution, as you can see here, that is pi. When k equals 0. Any question? So next equation is like 2 times cosine of 3 theta equals 1. So this time, instead of theta, 3 theta is given here. So we will solve for cosine first, and then figure out what 3 theta can be, and then we discuss the solution theta. So cosine of 3 theta equals 1 over 2. So the first step is solve for 3 theta. One and two are involved, so that is involved to 30, 60, 90-degree triangle. And obviously, that is related to pi over 3. So pi over 3 is the reference angle of 3 theta. And we want to locate the angle. To do that, we observe that the cosine value is positive. So cosine value is positive when x values are positive. So those are located in the first or fourth quadrant. And we use the reference angle pi over 3 here. So when that is in the first quadrant, that goes as it should be. So that is pi over 3. And for this angle, this is 2 pi, which is 6 pi over 3. So this angle is 5 pi over 3. So we have two angles between 0 and 2 pi. So between 0 and 2 pi, 3 theta equals pi over 3. So when we generalize, we have to add 2 pi k, and the other answer was 5 pi over 3 plus 2 pi k. So to figure out theta, we divide by theta on both sides. So theta equals 1 over 3 times pi over 3 plus 2 pi k, or 1 over 3 times 5 pi over 3 plus 2 pi k. So we think about the distribution. So theta equals, let me write down 1/3 times pi over 3 plus 1/3 times 2 pi k, or 1/3 times 5 pi over 3 plus 1/3 times 2 pi k. So theta is pi over 9 plus 2 pi k over 3, or 5 pi over 3 times 3 is 9 plus 2 pi k over 3. So step 2, find theta. So we figured out theta. Those are general solution. And the web assign can ask you to find the solutions between 0 and 2 pi. When we do that, what you will do will be you will just plug in k equals 0, 1, 2 until you obtain the angle. Although either angle becomes closer to 2 pi or become larger than 2 pi. If k equals 0, then we plug in k equals 0 here, and so just these terms will vanish. So we get theta equals pi over 9 or 5 pi over 9. So let me write down theta. Theta equals pi over 9 plus 2 pi k over 3, or 5 pi over 9 plus 2 pi k over 3. If k equals 1, then of course we plug in 1 here. Then we get theta equals pi over 9 plus 2 pi over 3. K equals 1 and thus nothing. So we just copy this part. Or 5 pi over 9 plus 2 pi over 3. We want to make this one into one fraction. So we think about the common denominator. Obviously, common denominator is 9. So So 2 pi over 3 will be converted to 9 because we multiplied by 3 to the denominator and to the numerator together. And we do the same thing for the next one, 5 pi over 9 plus 6 pi over 9. So we have theta equals 7 pi over 9 and 11 pi over 9. If k equals 2, then we again just use this one, then theta equals pi over 9 plus 4 pi over 3. So 2 times 2 will make 4. And the next one is 5 pi over 9 plus 4 pi over 3. So when we think about the common denominator, that becomes pi over 9 plus we multiply by 3 on the denominator and numerator. 4 times 3 will make 12, 12 pi over 9. And 5 pi over 9 plus 4 times 3 will make 12, 12 pi over 9. So theta equals 13 pi over 9 and 17 pi over 9. So what you notice is it is pretty close to 2 pi because 2 pi equals 18 over 9 pi, right? So you can imagine that probably the answers are DH6. But for safety, we can check with k equals 3. If k equals 3, then theta will be pi over 9 plus 2 pi times 3 over 3 and 5 pi over 9 plus 2 pi times 3 over 3. And so what you see from the pattern, you see these two will cancel each other, and we have 2 pi here, and the positive numbers are added. So both two angles are greater than 2 pi. So we don't have to think about that. And the final answers will be these 6 answers. Any question? So 5 sine squared of theta minus 21 sine of theta plus 4 equals 0. This time we have to round to 3 decimal places. I didn't multiply 1/3. So could you clarify the page before? What we did was we solved for 3 theta, and then we obtained the value for 3 theta. But what we are looking for is a theta value. So instead of 3 theta, we have to figure out theta. So to remove this 3 in front of theta, I had to multiply by 1/3 on both sides. And that's the reason we got this. Any other question? So this time we are talking about the quadratic form of the equation. So what we will do will be, we will do substitution to make the equation look simpler. So x equals sine of theta. Then the equation is 5x squared minus 21x plus 4 equals 0. So we have to figure out the factorization. This is 5 times 1. And this is 4 times 1. The strategy is after we cross multiply, we have to get 21. So 1 times 1 will make 1, and 5 times 4 will make 20. When we add them up, we have 21. But we have to make minus 21. So we put minus to both, then we will get minus 21. Then we transfer this minus to here, and then we are done with the factorization. So x plus. So the factorization will be 5x minus 1 times x minus 4 equals 0. As I've been saying, you can use any favorite method. So we have 2 solutions. So one is 5x minus 1 equals 0, and the other is x minus 4 equals 0. So we add 1 on both sides. So 5x equals 1. So x equals 4. So on the left side, we divide by 5 on both sides. Then x equals 1 over 5. So from here, we are obtaining sine value. So sine of theta equals 1 over 5. And in this case, we have sine of theta equals 4. What we realize is sine value will never become 4 because maximum value of sine is 1. And this is impossible. So it doesn't cause any solution. So this time they're asking you to round to 3 decimal places. Obviously, that is about solving using the calculator problem. to get the reference angle of theta, we will use sine inverse of 1/5. And if you use your calculator, then you will get approximately 0.201. We want to locate the angle in the quadrant. We observe that sine of theta is greater than 0. So sine is greater than 0 in the first and second quadrant. So we locate the angle in the first and second quadrant with the reference angle sine inverse of 1/5, which was approximately 0.201. So for this one is 2 pi. So you have to use your calculator. And we calculate this angle by doing 2 pi minus 0.201. And then that is approximately 2.940 plus 2k pi. Just so you will use your calculator. So any question? So we are getting two answers. So one is 0.201 plus 2k pi, and the other one is 2.940 plus 2k pi. Why 2 pi at 180? Of course, this is 180 degree, the pi. Thank you. So pi. So pi minus 0.201. So any other comment? We will do one more problem in this section, and then we are finishing with this section. I think the next problem is the pattern of the problems, which we already solved last time. Two cosine square root of theta minus sine of theta equals 1. So if you want to solve this type of problem, then what you have to do is you have to convert this one into one pattern of the equation. So cosine and sine are combined. So we will convert that into sine and cosine, sine related equation. We use Pythagorean formula. So cosine square root of theta plus sine square root of theta equals 1. Then cosine square root of theta equals 1 minus sine square root of theta. So we will replace cosine square root of theta by 1 minus sine square root of theta. So 2 times the given equation becomes 2 times 1 minus sine square root of theta minus sine of theta equals 1. So that is 2 minus 2 sine square root of theta minus sine of theta equals 1. So we move this one to the left side by subtracting. Then we have 2 minus 2 sine square root of theta minus sine of theta minus 1 equals 0. So we have minus 2 sine square root of theta minus sine of theta plus 1 equals 0. And so we multiply by a negative number, minus 1 on both sides. Then we have 2 sine square root of theta plus sine of theta minus 1 equals 0. So we have to factor. So 1 times 2 and 1 times 1. So 1 times 1 will make 1 and 2 times 1 will make 2. And when we add them up, we have to get 1. So this is negative 1. So one of them must be negative number. This time, this number must be 1. So we put minus to the second one, the smaller one. And then factoring goes like this. So sine of theta plus 1 times 2 sine of theta minus 1 equals 0. So we have sine of theta plus 1 equals 0, or 2 times sine of theta minus 1 equals 0. So we subtract 1 on both sides, then we have sine of theta equals minus 1. And for this case, we have 2 sine of theta equals 1. So sine of theta equals 1 over 2. Okay, so we are getting 2 answers. One is minimum sine, and this one we have to use a special triangle. So let's do case by case. So sine of theta equals minus 1. This is 2 pi. This is 3 pi over 2, right? So the solution between 0 and 2 pi becomes 3 pi over 2. So theta equals 3 pi over 2 plus 2 pi, okay? That's one of the solutions. And the other one is sine of theta equals 1 over 2. So we think about 30, 60, 90-degree triangle. 1, 2, square root of 3. So 1 must be opposite. So the angle involved is 30 degree, pi over 6, right? So we have to locate the angle in the quadrant. So sine is greater than 0. So that must be in the first or second quadrant. And this is pi over 6, and this is pi over 6. So theta equals pi over 6 plus 2k pi, or this one is 5 pi over 6, because when we add them up, we have to make pi. So 5 pi over 6 plus 2k pi. Any question? So that's it for 7.4. And we will move on the polar coordinates. Polar coordinates is not hard subject, but that is something new to you. And so you have to repeat it to remember the system, to be familiar with the polar coordinate system and polar expression. Let's talk about the rectangular coordinate system first. Rectangular coordinate system is the coordinate system we are familiar with. In the rectangular coordinate system, we have x and y axis. When we have a point on the plane, we can identify its x coordinate and y coordinate, and that point address can be uniquely written as x value and y value. In polar coordinate system, when we embed the polar coordinate system in the rectangular coordinate system, the right part of the x-axis is identified as polar axis, and the origin is called pole. So now we have a point in the polar coordinate. This point is denoted as P, and then the polar coordinate is written as R and theta. This R is the distance between the pole and that point. But that distance is oriented, which means this R may be a negative distance. So distance with orientation that means R may be positive or negative. And theta is the angle between polar axis and the line segment which joins the pole and the point. I said R is the oriented distance. So let me tell you what it means. So this is the polar axis. Let's say there is a point P, which is denoted by R and theta. And let's assume that R is greater than 0. And this angle is theta. So I'm saying that R is greater than 0. And so that is just exactly the distance between the origin and that point. And the other information it is carrying is that is plotted toward the angle direction. But we can think about the point which is located opposite direction. So this is R is greater than 0. And when we go the other direction, we can write minus R. And when we plot this point, the way we can describe that point will be minus R and theta. So this R, absolute value of negative R, is the distance between the origin and the plotted point. But negative means instead of going toward theta direction, we are going toward the other direction. So instead of we plot the point in the first quadrant, we are plotting the point in the third quadrant by using the angle theta. But we can describe the same point differently. That can be just a R, which is a positive number. And then what we know with the sign of R, which is positive, is the angle, which is described here, is on the toward the line segment which joins the origin and the point. So we have to write this angle. So this angle this angle is a flat angle, so we can describe that as 0 plus 180 degree. Theta plus 180 degree. As we could see there, we already noticed that there are two different expressions with the same given point. So the distinct nature of the polar coordinate system is we have infinitely many ways to describe the position of the point. So there are infinitely many ways to write the polar coordinates. Let's do some example about plotting. Plot the points whose polar coordinates are given. Give two other polar coordinate representations of the point one with R positive and one with R negative. The first one is 1, 3 pi over 4. The general process to identify the point will be, you will identify the angle first, and then you will think about whether the R is given as positive or negative. So we will think about the angle first. So this is pi. So this is 4 pi over 4. So angle is located in the second quadrant. And then what we notice is 1 is positive. That means the point must be located toward the angle direction. So this is 3 pi over 4. And all we have to do is plot the point where the distance from the origin is 1. So this is the point we have to plot. So what they're asking us is we have to think about other representation with R positive and R negative. So R positive means angle, direction, and R negative means opposite of angle, direction. So if R is positive, then of course I will copy the same R, and when we represent the angle, as long as that is the coterminal angle, it is okay. So you can add 2 pi or subtract 2 pi or any multiple of 2 pi. So I will just add 2 pi. Then it becomes 1, 3 pi over 4 plus 8 pi over 4. So it becomes 1 and 11 pi over 4. Let's consider when R is negative. When R is negative, we will switch the sign of R, but we have to consider the angle, which is opposite side of 3 pi over 4. So I said that opposite angle is obtained by adding pi or subtracting pi. So this time we will add pi to the given angle. So we have -1 and 3 pi over 4 plus 4 pi over 4. So that becomes -1 and 7 pi over 4. Second one is 3 and minus pi over 6. So as I said, the first thing you have to identify is the angle, and then second thing you have to think about is the distance. Depending on whether that is positive or negative, you will plot toward the angle or opposite of the angle direction. So this time we have minus pi over 6. So obviously that is in the fourth quadrant, and R is 3. So we just plot toward the angle direction. So R equals 3. So this is 3 and minus pi over 6. So as we have been doing, if R is greater than 0, then we will just look for the the coterminal angle because r is given as positive number and we are thinking about the same sign r. So 3 minus pi over 6 plus 2 pi, then that is 3 minus pi over 6 plus 12 pi over 6. So we have 3 and 11 pi over 6. If r is negative number, then we change the sign. So minus 3, because r should be negative, but we think about the other direction. So we can obtain that by adding pi. So minus pi over 6 plus pi equals minus 3 and minus pi over 6 plus 6 pi over 6. So that becomes minus 3 and 5 pi over 6. So any question? The next one is about 3 and 3 pi. So again, we will think about the angle location and then we will think about the oriented distance. So that is 3 pi. So this is pi, 2 pi, 3 pi. So that is identified with the negative x-axis. And the distance is 3. So we will locate that here. And this is 3. R equals 3. So that is the location of the point. So other routine will be the same. R equals is greater than 0. Then we think about 3 and 3 pi plus 2 pi. And then we get 3 and 5 pi. So we are getting the coterminal angle. And R is less than 0. Then that is minus 3 and 3 pi plus pi. So that becomes minus 3 and 4 pi. Let's do the next problem.
Why did you add 2 pi to the first one, but only pi to the second one?
So R is negative, right?
Okay.
So that comes from the negative opposite angle. So in this case, the angle is located here, negative axis, and so this must be on the positive x-axis, right? And then we go opposite to get this point, right?
Okay.
Yeah, and so we add pi, or just visually, definitely that is the multiple of 2 pi, right? Any other question? The next one is minus 4 and pi over 4. So again, we think about the angle and then the distance with orientation. So angle is located in the first quadrant, and that is pi/4. And we have to plot it, but this time this is a negative distance. So instead of going toward the angle direction, we will go the other way. And when it becomes distance 4, we plot there, and then that is -4 and pi/4. So this is kind of flip the problem, because this time the distance is given as minus. So let's say r is greater than 0. Then instead of going from pi/4 to the other direction, we have to go from the angle itself, right? And so after we write the positive r4, we will write this angle. This angle is pi/4 plus pi, right? And so that becomes 4, and pi/4 plus pi, 4 pi/4. And so that is 4 and 5 pi/4. And then r is negative, and r is negative from the beginning, so -4. And then we will think about the coterminal angle, so pi/4 plus 2 pi. So that is -4 pi/4 plus 8 pi/4. So that is -4 and 9 pi/4. So any question? Let's do a little bit more. The next thing I want to talk about is relationship between polar and rectangular coordinates. The way I presented the polar coordinate was by embedding the polar coordinate in the rectangular coordinate system. So this time we want to explore the relationship between polar and rectangular coordinates, and how we can convert polar to rectangular coordinate and rectangular coordinate to polar coordinate. So we have a point here. In polar coordinate, that is expressed as r and theta, and in rectangular coordinate, that is expressed as x and y. The question we are dealing with is how to convert polar to rectangular and rectangular to polar. To do that, what we do is we think about the Pythagorean formula, and we draw the right triangle here. This is theta, and This horizontal leg is x and this vertical leg is y. And let's say hypotenuse is r. Then r squared equals x squared plus y squared because of the Pythagorean formula. We also know that cosine of theta in rectangular coordinate definition is x over r. And sine of theta was defined as y over r. And the tangent of theta is defined as y over x when x is not equal to 0. So from this definition, we can re-express the rectangular coordinates x by r times cosine of theta. So we know the polar coordinate, then the x coordinate can be calculated by using this formula, and the y equals r times sine of theta. So first one is change from polar to rectangular coordinate. X equals r cosine of theta and r equals sine of the y equals r sine of theta. So that's what we already showed. The next thing I want to talk about is change from rectangular to polar coordinate. In that case, we will use the formula r squared equals x squared plus y squared. When x and y coordinates are given, we can think about the square root of x squared plus y squared. And when we figure out theta, we will use the tangent formula y over x. And when x is not equal to 0, of course, we have to think about the inverse tangent and the location of the angle. So let's do just one more question. The next question is find rectangular coordinate for the point that has polar coordinates of 4 and 2 pi over 3. So r equals 4 and theta equals 2 pi over 3. So when we plot the point, 2 pi over 3 is obviously located in the second quadrant. The distance is 4. So this is 4, 2 pi over 3. So we will use the formula. So r equals x equals r cosine of theta. So r is 4, and we calculate cosine of theta is 2 pi over 3. So this is pi over 3, and cosine is negative here. So we can write it down as 4 times minus cosine of pi over 3, which is 4 times minus 1 over 2. Just we know what that is, right? So minus 2. I don't like to draw the special triangle. So y equals r sine of theta, that equals 4 times sine of 2 pi over 3. So sine is positive in the second quadrant because y values are positive. So that equals 4 times sine of pi over 3. So that is 4 times square root of 3 over 2, which is 2 square root of 3. So the rectangular coordinate we can obtain from the polar coordinate for 2 pi over 3 will be minus 2 and 2 square root of 3. Any question? All right, I will finish my lecture here, and if you want to speak with me, then you will remain.
Okay.
Otherwise, you can leave.
Thank you.
Mm-hmm.